Hello all, this is Dr. Alsop, and today we will be discussing the basic structures of the brain. Now, I want to note that this is a very superficial survey of the brain's gross structure. You will take a deeper dive into the functions and deeper structures of the brain in your neuroscience sequence later in your education. We mainly want to focus on the areas of the brain that will help you in your understanding of the neurovasculature and the meninges, so very big picture concepts here. So no surprises here, let's learn the major parts of the brain. Alright, when you think of the brain, just think about your first thoughts when somebody says the word brain. What do you think of? You think of something kind of similar to this, I would imagine. The majority of us consider what is referred to as the cerebrum, and this is very fair because this is the largest component of the brain. The cerebrum includes the cerebral hemispheres, which you can see the right hemisphere here and the left hemisphere here. So it will include these cerebral hemispheres as well as basal nuclei or subcortical nuclei, which you cannot see here. Some of those deeper structures we aren't really getting into. You can see that the cerebral hemispheres are separated by this longitudinal cerebral fissure, so a very dominant fissure between the two parts of the cerebrum. And during life, there will be a dural partition associated with this region, which is that large falx cerebri. A few other dominant things you can see from this image are these folds or ridges of the cerebrum, so you can see it kind of all over the place here. These are the gyri, or the gyrus, if you're talking about the singular. These create a larger surface area for the brain, which lends to greater cognitive function. So that's the gyri are giving that folded appearance to the brain. And you can also see the grooves and depressions that are going to be between the gyri, and these are referred to as the sulci. These are on a much smaller scale than the larger fissure that you can see here in the longitudinal cerebral fissure. The cerebrum is also separated into various lobes. These are named after the surrounding bones, but it's important to note that they do not match up exactly to those overlying bones. So your frontal bone would lie kind of in this region here, but there wouldn't be an exact match with the frontal lobe and the frontal bone. But the same general areas that can kind of help in terms of being able to identify where these lobes are located. Alright, in this image we are looking at a sagittal section of the brain. We often refer to this as a hemisected brain. You'll hear us say that quite often. When we're looking at this, we're looking at a left hemisected part of the brain, and we're looking at the inside of the brain. So we're looking at some of those deeper structures. Also, it gives you a better view of some of the structures you can see externally, specifically that brainstem. So let's start up here first. You can see this large cerebral cortex, so some of those gyri that we talked about and the sulci associated with them. Also part of the cerebrum, you can see the corpus callosum, which is important in communication between the right and the left cerebral hemispheres. Now let's move down into structures that are not part of the cerebrum. This region right around here-ish is referred to as the diencephalon. This one is a little odd one. It's often described as the central core of the brain, and it is not visible at all from an external view. So, while these are deeper structures, they're good to know that this exists, but you do not have to identify these at this time. The diencephalon will consist of the epithalamus, the dorsal thalamus, and the hypothalamus. Now let's move into the brainstem. You can see the brainstem from an external view, and we'll see that in some of the arterial videos and some of the cranial nerve videos that we have later on. But I think it's particularly nice to look at the brainstem from this sagittal section. You're going to have three components of the brainstem. You will have the midbrain, here-ish, the pons, here, and the medulla oblongata. And the medulla oblongata at the foramen magnum will transition into the spinal cord. We will discuss, as I mentioned, the brainstem in a bit more detail when we discuss the origin of the cranial nerves, as most are coming from this region. The cerebellum, which you can see back in this region here, so kind of posterior to the brainstem. Has a similar organization, but certainly not necessary in terms of function, so you don't have a similar function with the cerebrum and the cerebellum. But the cerebellum also has two hemispheres. It will have a right and a left hemisphere as well. Alright, so this is your super big picture introduction to the brain structures. As I mentioned before, you will get into greater details in subsequent sequences in your educational career, but this will help in terms of being able to understand where certain cranial nerves are going to originate or where the arteries are going to supply. Okay, so let's think through this question together. Which structure is considered part of the brainstem? Is it A, cerebellum, B, cerebrum, C, diencephalon, D, pons, or E, right hemisphere? So take a moment, you can pause the video if you need to, but if you're ready to move on, hopefully you have landed on D as the correct answer. The midbrain, the pons, and the medulla oblongata are components of the brainstem. Your cerebellum is close to the brainstem. It's going to be posterior to it, but is not part of the brainstem. The diencephalon is part of the core of the brain, not part of the brainstem. The right hemisphere could be either the cerebrum, the right hemisphere of the cerebrum, or the cerebellum, but not of the brainstem either. All right, so review this material and make sure that you have these basics down before you get into the neurovasculature of the brain, as we will be mentioning many of these structures throughout. Thank you for your time and have a great day.